NASA just shut down part of Voyager 1, but it's the smartest move to keep it alive in the interstellar space. Just days ago, in mid April 2026, engineers at NASA's Jet Propulsion Laboratory had to make a heartbreaking decision. To keep the humanity's farthest scout alive, they had to pull the plug on a legendary piece of technology. They sent a signal across the cosmos, a signal that took 23 hours just to reach the spacecraft, ordering it to permanently shut down. Its Low Energy Charged Particle Experiment, or LECP. Why? Because Voyager 1 is literally running on fumes and its power margins are now razor thin. One wrong move, one tiny drop in voltage could have triggered an automatic shutdown, putting the entire mission at risk of permanent death. But this isn't the end of Voyager. This is the ultimate survival story of the little probe that is still out there whispering the secrets of stars. They are buying time for one final, highly ambitious rescue plan. They are literally calling it the Big Bang Plan. They could bring it back online, and today we are diving deep into the latest nail biting update on Voyager 1, what just happened, what we lost, and how NASA plans to cheat death one more time. If you are a space lover like me, then Voyager 1 is basically the longest distance love affair in the universe. A spacecraft no bigger than a car, launched back when Star Wars was still in theaters, and now the farthest thing humans have ever built, over 15 billion miles from Earth, and it's been screaming data back to us for nearly 50 years, longer than most of us have been alive. This probe has defined what it means to push the boundaries of human exploration. NASA just reached across the star and shut down one of its last working eyes. Not because it broke, but to keep the whole mission alive just a little longer. Voyager 1 is powered by a radioisotope thermoelectric generator, or RTG. It uses the heat from the decaying plutonium 238 to generate electricity. But plutonium decays every single year. Voyager loses about 4 watts of power capacity. For nearly 49 years, it hasn't been a massive issue, but fast forward to April 2026, we have hit a terrifying threshold. According to the latest press release from NASA, Voyager's power margin have become incredibly tight. Engineers were terrified of a specific scenario, an undervoltage fault. Recovering from an automated fault shutdown is incredibly risky and complicated process. So Mr. Karim Badruddin, the Voyager mission manager at JPL, and his team decided to take manual control. They needed to sacrifice an instrument to save it. Now let's talk about the logistic of turning off a switch in interstellar space, because it's mind-bending. When you want to turn off a light in your room, it happens instantly, right? But when NASA wants to turn off an instrument on Voyager 1, that far away, they have to send a radio command 15 billion miles or 25 billion kilometers into the void. Even traveling at the speed of light, that command takes 23 hours to get there. Imagine hitting send on a text message and having to wait an entire day just for it to deliver. That means the team at JPL was sitting on the edge of their seats for almost 50 hours, just waiting for the communication that the spacecraft survived the procedure. On April 17, 2026, NASA sent the command, and once Voyager received it, the shutdown process itself wasn't a quick click. It took painstakingly slow 3 hours and 15 minutes for the LECP to safely power down. Now this wasn't just a piece of metal, it was our eyes and ears for the invisible storms of the cosmos. The LECP ran almost continuously for 49 years. However, its original mission was just for 5 years, to fly by Jupiter and Saturn. It was designed to measure ions, electrons, and cosmic rays originated from our solar system and the wider Milky Way galaxy. It used this brilliant trick called gravity assist, basically using the planet's gravity like slingshot to speed up and change direction without burning extra fuel. And interestingly, the outer planets were perfectly lined up in a rare alignment then. That wouldn't happen again for 175 years. The Grand Tour opportunity. Budget cuts scaled it back, but Voyager 1 and its twin Voyager 2 were built tough. Now, fast forward to March 1979. Voyager 1 swings past Jupiter. It catches something mind blowing: active volcanoes on Io, one of Jupiter's moon. First time anyone had seen volcanic activity anywhere beyond Earth. Then, November 1980, it crossed the Saturn, those iconic rings, and the hazy giant moon. That Titan flyby. Actually, Voyager 1 was sending a one way ticket to the stars. But in 1990, NASA rebranded the whole thing as the Voyager interstellar mission. The goal was to reach the edge of the sun's influence and keep going. And boy, they did deliver. On August 25, 2012, Voyager did the impossible. It crossed the heliopause, the invisible boundary where sun's charged particle wind finally gives way to the stuff between the stars. And boom, the first human-made object in the interstellar space, Voyager 2, followed in 2018. It was the instruments like the LECP that confirmed it. It mapped the pressure fonts, particle densities in a region of space humanity had never touched. Without it, we are a little more blind out there. With the LECP gone, Voyager 1 is down to just two operational science instruments. One that listens to the plasma waves and a magnetometer that measures the magnetic fields. By the way, its twin Voyager 2 had its own LECP turned off back in March 2025. Before it, as JPL noted, shutting off a science instrument is nobody's preference, but sometimes it's the best option on the table. By shutting down the LECP, engineers estimate they have bought Voyager 1 about a year of breathing room, and now they are going to use every single second of that year to prepare for something wild. NASA calls it the Big Bang. No, they aren't blowing the probe up. The Big Bang is the nickname for the highly ambitious, all at once energy saving fix that engineers are finalizing for both Voyager 1 and 2. Because power is so tight and turning things on and off individually is getting too risky, the plan is to swap out a whole group of powered devices simultaneously. They are going to shut off specific legacy systems and replace them with the lower power alternatives within the probe's ancient computer architecture. They are testing it first on Voyager 2 this May and June 2026. It has a tiny bit more power margin and it's closer to the Earth, so it's safer. If it works, they will try to on Voyager 1 no earlier than July. And if the Big Bang works, it could squeeze a few more precious years out of these historic spacecrafts, pushing their operational life maybe till 2030s. Voyager 1 isn't just a probe, it's a time capsule of humanity. It carries the golden record, humanity's message to the cosmos, greeting in 55 languages, music, sound of Earth, but more than that. The story of Voyager 1 is the ultimate story of human endurance. It's a machine built with less computing power than the digital watch on your wrist, yet it continues to unlock the deepest secrets of our galaxy. And in November 2026, Voyager 1 will hit another milestone: one full light day from Earth. 24 hours of one-way signals. Yes, the lights are turning off one by one. The LECP has joined the cameras and other dormant instruments in the cold dark. But every time NASA shuts down an instrument, they are extending the heartbeat of the mission. It's a reminder that exploration doesn't have to be flashy or new. Sometimes the greatest science comes from a 49-year-old spacecraft, and that's just still going. What do you think? Will the Big Bang update work and keep Voyager 1 alive till 2030s, or are we finally witnessing the final days of our greatest interstellar scout? Let me know your thoughts in comment below, and don't forget to like and subscribe the channel, and I will see you in the next video.